Wir sind ja hier nicht zum Spaß, ne?
Okay. 1 Uhr nachts hast du es jetzt, ne?
Ja.
Sehr gut. Stolze, starke Leistung.
Großartig.
So, scheint zu klappen.
Ja, irgendjemand hat mir gerade das Bildschirmteilen weggenommen.
Echt?
Ja, eben hatte ich ja meinen Bildschirm noch geteilt und jetzt ist es weg.
Ich probiere auch noch mal ganz schnell was hier. Ich muss nämlich noch mal den...
Jetzt seht ihr mich wieder, ne? Also den Bildschirm.
Ja,
Ja.
mein Bildschirm sehe ich.
Ja, ich stoppe. Alles klar, ich bin wieder raus.
Boom, jetzt ich noch mal schnell und da sind wir jetzt alle fertig. Super.
Ja.
Leider kein Inhalt bei dir, aber normal, ne?
Nee. Das ist ja schon immer so gewesen, ne?
Was ist denn das für ein Rumgehacke auf den armen, verschlafenen Mann?
Ja, genau. Jetzt lass doch mal den armen Ami in Ruhe.
Du musst den Puls mal ein bisschen hochbringen. Du musst den Puls hochbringen, dass er nicht einschläft.
Frankfurter Applaus, ne? Schön mal zum Thema.
Genau das. Kennt sich aus, ne?
Auf jeden Fall. Habt ihr lange genug in Frankfurt gearbeitet?
Ja.
Ach Mensch. Ja, irgendwie funktioniert das heute mit meinen Fenstern hier viel, viel besser. Ich habe meinen Zoom auf nur ein Fenster beschränkt, anstelle von irgendwie überall und irgendwie Screenshare und so ein Quatsch.
Sag ich doch, du musst mal 3 von den 5 Bildschirmen abklemmen.
Naja. So, wie viel haben wir denn jetzt hier schon?
Keine Ahnung, 35.
Schau doch mal, wer ist denn da jetzt so? Kenne ich da jemanden?
Ja, ich sehe schon Norwegen, Deutschland, Holland, England, Deutschland. Moin Jens.
Müssen wir jetzt auch mal langsam wieder anfangen, Englisch zu reden, ha?
Ja, wir könnten. Wir könnten.
Könnte man ja jetzt mal, wenn man wollte. Ja, unglücklicherweise sagt mir dieser kleine Name irgendwie was.
Achso, übrigens müsste ich vielleicht mal mein Telefon noch ausschalten, ne?
Da habe ich ja den Vorteil, ich habe ja keine Freunde, mich ruft ja keiner an.
Jedenfalls nicht nachts um 1.
Hat Vorteile, ne? Mit der Geschichte.
Ist sowieso auf Ruhestörung eingestellt. Deswegen hast du auch die Mailbox gekriegt, wenn du mich vorher angerufen hast.
Naja. Yeah, I guess latest now at 10 o'clock in the morning of Central European time, we should switch to English in order to allow everybody to understand us. Hopefully everybody.
Okay.
Stefan, one applause for you in the very beginning for being still awake at 1 o'clock in the morning.
Yeah, cheers.
Enjoy your coffee or Red Bull, whatever it is.
It's water.
White wine water.
Yeah. White wine schorle.
Yeah, I think we can wait 1 more minute just to allow more people to log in.
Do we know how many people signed up today?
My last status or my last information was from last week Friday, and there we had around about 90. Now we have 47 participants still climbing. Let's see, but it's usual that there are always more registrations than participations.
Christopher Dietrich, ist das der Krieger Dietrich? Schick mir mal einen Chat, wenn du das bist, Mister.
Bisschen mehr Kontenance jetzt bitte hier, ja? Die ganze Welt hört zu, Stefan.
Ja, echt? Auf meiner Hälfte schlafen die hier. Martin Laut. Oh, Dubai is here.
Yeah, okay. I guess we can start. Good morning, everybody. And welcome to this webinar, which we started to create already a few months ago, but it was a little tricky to organize us together, to find the dates, to prepare the webinar. So it took a little longer than expected, but doesn't matter.
Oh.
Yeah. first of all, I would like to describe the initial idea to this webinar, where it came from and why we chose this topic. A few months ago already, I had a webinar together with Jeff Reeder from Clark Reeder Engineering and with Joe Ciampelli from EPS. And we've been talking about event engineering and the differences in event engineering. So from a theoretical point of view, the differences between Europe and the United States, or the American market and the European market. So this led me to search for two guys who I could talk with about the differences from the practical point of view. And finally, I came up or found Chris Böttger and Stefan Priese to do with me, together with me, this webinar. Thanks a lot in the very beginning again for your assistance, for your time. And yeah, we were looking for a discussion about the practical differences or the differences in practice. So finally, we agreed not to talk about exactly what I've intended to talk about in the very beginning, but nevertheless, now we ended up with discussing about the technical view, how to plan the installation or the setup of a video wall. Yeah, basically in the very beginning, some rules how we will handle this webinar. I'm basically more or less acting as an anchorman or as a moderator that will hand over or who will moderate the discussion. Of course, I can contribute as well with some knowledge and topics, yes, but most of it will be handled by Stefan and Chris. The chat is open for everybody, so you can write between each other, between the participants. The Q&A function is open for questions. If you have any questions about whatever we are talking, please use the Q&A function. I will have a look in it constantly, and will hand over the questions to Stefan and Chris or me, whoever can answer that best. So let's see. Yeah, what it's about, basically, it is that we will discuss about what are the necessary steps and thoughts for a technical correct, detailed planning of a ceiling suspended LED wall. With this question or with this topic, we scratch only the surface of the whole topic, that's for sure. And in order to discuss all the theoretical backgrounds, we would need to create at least one or two other webinars, especially when we are talking about leveling of the truss and the lifting of the whole assembly. And we would have to go way deeper in the maths. So yeah, once again, we will just scratch the surface. Otherwise, we would not have enough time for it. All explanations that we will make now within this webinar are related to a project which Chris Böttger handled in 2019. It was a concert tour of the artist, of the German singer-songwriter artist Philipp Poisel. And it was a tour with 13 indoor shows traveling throughout Germany, or was it abroad as well?
Austria and Switzerland.
Austria and Switzerland, so basically within the German-speaking countries. And the audience was between 10 to 15,000 people for every show. And just for you to have an understanding what it looked like finally is this one view. It is one huge back wall and two smaller vertical oriented LED screens, a little bit more on the downstage side. This is another view from the front. Yeah, and that's it basically. I can now already hand over to Chris, I guess.
Yeah, thank you, Norbert. So I just want to introduce myself before I start. Yeah, I had my first contact in our industry as a stagehand in 1982. So I started sport climbing at the age of 15, and heights have always fascinated me. I founded my company, Truss Rigging Service, in 1989. The main activity is the realization of tour productions in the field of rigging. I also advise companies in risk assessments and system selection for special projects. Yeah, my second field of activity is as an education provider, and such I am active in rigging education as a lecturer. My acceptance is accordingly large due to my touring activities. 15 years ago, on a beer whim, I wrote a technical book on the subject of rigging. It was the first technical book of this kind, which is still used today as a textbook for training and as an event technology specialist in school. I'm part of the working group of the SQQ, which started the rigging qualification here in Germany. Since 2000, we have the training standard, which is unique in this form from Europe. In contrast to other countries, we don't have just an exam, but there is a proper training in the individual disciplines. Currently, I have a new challenge. I work as a production manager for a very popular German rock band. Unfortunately, we can't go on tour, but it's another theme. So I'm happy to be here today and try to explain the rest of the world, my view, what parameters are important for the planning and the execution of such a project. Fasten your seatbelts. I wish you and us a relaxing 4 hours, maybe. Yeah, Norbert? Okay, just kidding. We are only prepared for 3 hours, so take care.
No, I guess so the plan is that it will be round about 1.5 hours. Let's see.
Okay. So yeah, then
by the way, I just forget in the beginning to ask Stefan as well for introducing himself, and I didn't introduce myself as well. So I just want to do this and interrupt you again. Sorry, Chris, but yeah.
No problem.
My name Norbert Tripp. I'm the technical director of Area 4 Industries, and Area 4 Industries, for those of you who do not know who is behind that, it is a group of several manufacturers of trusses, which are Litec, ProLite, Milos, James Thompson Engineering, and Tomcat. We have different manufacturing plants all over the world, 4 different ones in China, Czech Republic is the headquarter, Italy, and in the United States. Yeah, we are manufacturing different kind of trusses, and we are manufacturing as well different kind of, we are manufacturing and offering different kind of other products from the staging and rigging industry in total, in general. By the way, we will send over a handout. That means a PDF of this webinar in the after the second version of this webinar, which will be next week, Thursday. So of course, it's worth to make some notes, but just for you to know, you will have, you can receive a PDF of it later on. Yeah, that's it. Stefan, what about you?
Yeah, I'm still awake. So my name is Stefan Priese. I'm born and raised in Germany. I started in our industry in the mid-90s, and I did my rigging education in Germany in 2000 in one of the first courses that there were. In 2007, I moved to the United States, and that's where I'm stationed right now, working for Creative Technology here in the United States in Los Angeles. And I'm currently the rigging and LED engineer for Creative here in the US. And basically, I'm helping and designing custom solution, custom LED screens, and supporting everybody that needs it with anything LED and rigging related.
Yeah, thank you, Steph. There's already one question in between. It would be nice to have access to the full video as well. Yes, of course. We will upload a video of this session as well after the second session. It will be uploaded on the homepage www.a4i.tv, which is a rigging and trussing the television channel from Area 4 Industries, where you can find as well the previous webinar that I held with Joe Ciampelli and Jeff Reeder, and many, many other educational videos, product videos, on-site videos, and whatever you would like to share with us to be published there as well. Just let us know, have a look, and enjoy that homepage as well. Okay, now I guess it is now up to Chris to share his screen and to explain what he did basically in 2017.
Okay, so I hope you see my screen. It's perfect, yeah? Okay. Then, the first, or the idea is, the first working basis is the rough design idea, which shows the top view of the stage with the planned light trusses and the video wall or video walls. We have 3 of them totally. So this design template gives us the first impression of what we are talking about and the positions of the walls which are planned. So this plan does not yet include the final system selection and the position and the number of the required suspension points and for example, also the chain hoists. The trusses, or the trusses which are shown, are pure CAD symbols and thus do yet not stand for specific construction type, which will be defined later. So there will be 3 video walls in use, a large one behind the stage, which makes it almost the entire width of the stage, and 2 smaller walls on the right and the left, and the height of the center of the stage, so viewed lengthwise. I'm now interested in the first step. I need to know the size, the position, and the weight of the planned panels. So therefore, I grab the data sheet of the manufacturer, and I can find the required information due to the panels about the size and the dead weight of a single module. So well, this is a start, but it's not enough to create a preliminary plan. So what we have so far, we are talking about 3 walls in 2 different sizes. We know the size and the dead weight of a single module, and we know the desired position in relation to the stage. What information are we still missing? How did the modules go up, or what does a possible flying frame looks like? How many suspension points will be there, or will be there, and do we need? And sorry, and what is the distance between the individual picking points? What are the technical details of the pick points in terms of texture and size? Is it possible to make the connection directly with a bolt and a shackle, for example? How heavy is the additional mounting material, including the cable weight? Is there already a statical consideration of the whole system from the manufacturer, from the wall, or from a similar project? After that, I can create a preliminary plan. So that means the next step is I have to go to the different departments and check, lots of information. So I have to know where do they plan what kind of installation. So I need to get informed by the lighting, by the sound, and by the video departments, and also by the stage manager. I want to know the stage size of the production manager, because I need to determine and brought together these informations in a preliminary plot. So what you see now is also a top view, and now we have included new symbols which are serve as a motor point and shows the position of the hoists. That means in this state you can see that we have different kind of symbols for the different hoists. So since the motor symbols are not standardized, bullshit, sorry. The legend is required on the plan, and so recipient is able to differentiate here. So if you have the legend, then you can see, okay, it's a 1 ton, it's a half ton, it's a quarter ton, it's a D8, it's a D8 plus, whatever. I think such a plan is also elementary for further arrangements and for system selection. So there you see what we have to that moment. We have a truss on 6 hoists, but before I go on there, Norbert, please, can you take over?
Yeah, of course. Basically, this is what you have done so far when you received the very first design or the very first proposal of the designer, of the show designer, and you made your first thoughts about how the rigging structure can look like. That's from your point of view. Now, let's imagine what happens if this tour would not go through Germany only, but if it would go over to the United States. So the question is, Stefan, what is your point of view? How would you handle this request in case Chris would contact you? Hey, CT guys, please serve a tour with your services to hang an LED screen. What would be your processing of that?
All right. Well, there's a lot of similarities about the whole process there, and I believe I probably should start with sharing my screen first.
Yep.
Which should be, oopsie.
Helpful.
Oh. This guy over here. All right, there you go. Should be able to see that.
Yeah,
right, so
sorry, Stefan, we see your not the final screen.
Mode.
We see your just
that guy?
Mode.
click on the top left swap displays.
Swap displays right there. How about that?
That looks better.
That much better. All right, cool. Well, you could get my secret notes there. Anyway, all right. So obviously, there's, like I said, there's a lot of similarities in terms of planning for that, and everything starts with what did you guys use before on your previous tour legs, what kind of product, and basically that's what I'm looking at first. Like Chris said, obviously we're looking at dimensions there. We're looking at brightness when it comes to LED, but obviously we particularly have to look at weight as well. So again, dimensions, weight, the brightness matters, and when we consider LED, obviously we also need to look at resolution and also the processing. So once I know what was used prior, then I can make a first stab at the products that are available in our rental pool. And what I use for that first initial selection is basically a software that one of our technical directors programmed and designed. It's called Fido LED. Can be downloaded under this website for free for PC, for Mac, even for iOS and for Android. I think the Apple version costs a little bit because Apple makes you pay for all that stuff nowadays. But anyway, so this is pretty much the largest LED database that I'm aware of from manufacturers and actual products itself. And that's where I'm basically punching in the raw data. What kind of power system am I using? I have a drop-down menu if I want to go by meter, feet, LED panels itself, and then I can punch some basic information in, and that gives me a resulting window here where I get a total panel count, I get rough dimensions, I get a pixel count, I get an aspect ratio, and I also get weight down here, get a wall weight. And of course, I can print that out. This way it's easily emailed around. There's also power consumption here that can be shared with the electrical department. And so, yeah. And so with that software, I'm basically finding the best match of what we're trying to do, what we're trying to achieve. And then I basically take a piece of paper and I make a one-by-one comparison. Usually I scratch that on the spec sheet from the previous product and then scratch my information right next to it. So in this particular case, I was choosing the Row Vanish 8S, which is also a transparent product. And it got an 8mm pixel pitch, which obviously outforces or outpowers the 20 millimeter pixel pitch that the infrared has there. The dimensions are roughly the same, 15 meter versus just under 15.5 meters. So that is obviously close enough. The height is even closer, 7 meters versus 704. And that's where the weight comes in, and that's where the real drastic differences are obviously coming to daylight there. 934.5 kilograms versus just over 3,000. If that doesn't make a rigger happy, then I don't know what else I can possibly do there. So, and of course, there's also to consider the active panel count. So the same dimensioned wall can be built out of 105 panels, because the panels are basically 1 meter by 1 meter versus 265. So everybody that touched LED panels before, if I can cut my work process in half and panel count in half, that makes it even so much further. So that proposal, that panel proposal, I'm basically sending it off to the production team and say, look, this is what I think would be the best match. What do you think? Here's the rough data. Look at it and let me know what you think. And once I get that approval, basically, and say, yeah, looks good, let's start working on that, and let's get the details nailed down, what is actually necessary, then I basically start the next step. In this particular case, or in most of the cases, I start selecting my rigging hardware. Do we have any bumpers or LED headers that have a certain dimension, certain size, certain rigging requirements, hanging points, etc. So I'm dealing with that. Once I have all that hardware selected and figured out how do I want to suspend my LED screen, I'm basically making a detailed drawing of that. And what I oftentimes do, especially when it comes to custom LED screens, whether they're ceilings or curved LEDs or something, I make that drawing a communication piece. So if there is some colliding gear that initially doesn't work out, I basically point that out in my drawing, and we talk it over then in the process with the team, and we're basically resolving those issues. And
Stefan,
having
Stefan, one question in between. There was someone raised the question, which software, you're just talking about drawings and so on, and some people have been asking for what kind of software do you use? That means you, Stefan, and Chris as well, for your initial
drawing software.
Yeah.
We at CT, we use Vectorworks, which I find very good in terms of they're catering to the entertainment industry, and it has the advantage that basically import and export of DWG AutoCAD files is fairly easy. A lot of rigging companies here in the US, they work with AutoCAD. And so having the capability of converting those drawings back and forth makes it fairly easy. And everybody that knows AutoCAD is familiar with the fact when they're receiving a Vectorworks drawing, then there's conversion issues. You have to have special plugins for AutoCAD. And from a couple of years ago, what I know, those plugins aren't really perfect. And I actually have yet to find problems with AutoCAD import into Vectorworks.
Yeah, yeah. And Chris, how about you?
I'm using AutoCAD, but the plot, which I showed you before, it was Vectorworks plot. So, I mean, AutoCAD is the base for me because for about 30 years, for 25 years, I'm using products like that. It was AutoSketch in the beginning, and then it just went over to AutoCAD. And my problem with Vectorworks is that many companies who are working with Vectorworks are blowing their plots up to 200, 300 mega MBs from a data size, and that's I can't deal with that on going out with the tour and sending out plots. I need a plot which is very small. That's the reason why I'm using AutoCAD. And if the plot is bigger than 1 MB, there must be a mistake somewhere in the AutoCAD thing.
Yeah, okay. Getting my drawings yet.
Okay, Stefan, back to you.
All right, good. So obviously make a detailed drawing, and actually in the United States, it's actually also required to have proper documentation for every individual screen and every single setup there. So, and then basically out of that drawing, I'm creating a complete gear list that I can pass on and share. So here's, for instance, a sample of how a drawing, or at least the front view of one of my drawings would look like. We have our LED panels. We see here the individual headers over each column of the LEDs. And then you see already a couple tails here, which basically are the turnbuckles and shackles, etc. But the most important points in this particular case is the offset from the outer edge, and then the distance between every single hanging point, which is basically symmetrical. It basically implies that there is a center hanging point over every single column. So that red and blue grid, by the way, is also generated. It's a PNG file that is generated by that FIDO database that I mentioned earlier, and I'm utilizing the grid in my drawings to showcase panel count and basically an easy overview. Like Chris said, those drawings can blow up really quickly, and if you have too many details in there, the sizes are just crazy. Then once I have that done, obviously, this is one of the gear lists that I'm also generating out of Vectorworks. It's basically a custom report that I'm making out of it, which gives me all kind of details, gives me total count of gear, gives me a little a symbol and a little bit index. What am I looking at? What is it? The name of it, and then obviously the individual weight per item, and then the combined weight in metric or in imperial data. So what's important about that whole thing is we looked earlier at our information. We were talking about that LED wall is about 934 pounds, which is obviously read and generated out of that FIDO LED. I got a little a screenshot here from that. And that's basically the number, but the software obviously doesn't know, the FIDO software doesn't know if it's a suspended screen, if it's a ground supported screen, is it somehow custom, what additional components are there, etc. So just utilizing that number, sending that PDF to your rigger and saying, here you go, here's your wall weight, this is what you're dealing with, is obviously only half the truth and gets you really quickly in trouble if you ignore reality. The reality being, in this case, obviously all the other components, where we have the headers, the shackles, etc. I mean, Chris can probably sing a song about how many shackles are on a tour production, and if you add that weight up, that is easily a couple hundred or a couple thousand pounds, depending how big your production is. In this particular case, when we add it all up, including our estimated cable weight, basically we're looking at an additional 300 kilograms that we obviously need to consider, and that gives us ultimately a total weight of those 1,287 pounds that I then take take my drawing, take the gear list with my weights in it, I bundle it up and send it off to my rigger to look at, that he can take my drawing and import it into his overall rigging drawing, basically.
Yeah, here I would like to step in because in our preparations for this webinar, in the very beginning, Chris and me have been looking a little bit, it looks like Stefan is still the picky German who is looking on on the every last digit. So you can see that the weight per item is shown with 3 digits after the comma. So it's very detailed. And but yeah, from my personal point of view, from a point of view as a structural engineer, I really like it to receive this kind of number, because when I receive the information that the screen weighs 1287.461 kilogram, I have the feeling, or I can assume, that it is a quite exact number which has been calculated somehow quite exact. If I would receive just the information 1300 kilogram, then I do not know. Yes, it is somewhat rounded, but why is it rounded? How is it rounded? Is it rounded on the safe side? Is it including all the details like shackles, headers, cabling, and so on? Or is it just the rounded weight of the screen? So when I receive the information, which is very exact, very precise, I already have a feeling that it is counted quite properly. And then I can finally, if I feel necessary, I can finally add a little safety, round it up to 1300, and that's it.
Yep.
So I like it definitely to receive this kind of detailed information.
Yep, it basically comes down to the more information you're passing on to your rigging department and everybody involved, the better. And so let the experts, the structural engineer and the rigger do the roundup. I give you the precise number that I know, that I weighed on a scale, etc., and that I have. And then you guys can do the safety roundups and all the fun stuff. That's not up to me. I give you the precise numbers as I know them, you know?
Yeah.
It's that simple.
Perfect.
All righty, Chris, I think that takes it over to you.
Yeah. Chris, you're muted.
Okay, now I'm here, back again. Okay, so yeah, the next question is, Steph, where can I sign to buy the product? No, the reduced weight and yeah, the number of modules are arguments that definitely play a role in the choice of a system. So you have probably been noticed that I've planned a truss between the video wall and the hoist suspension points. A so-called support truss between the wall and the hoists, which are used to set up and to move the wall at the final height, has many advantages. So the reduction of the number of suspension points between the wall and the supporting truss structure is in the individual venues, for example. I can route the system cabling away to the side sensibly and cleanly as required. And I can use also turnbuckles between the bumpers and the truss to level the individual modules. It's very important. And yeah, so the question is, what kind of truss do I want to choose, or which truss have I chosen? When selecting the truss, compact dimensions, the type of connectors, the wall thickness, and the course of the diagonal braces are decisive for me. The rectangular structure or the rectangular design always provides a higher load capacity than a square design with the same construction width. And the main support tubes, they have, with this system here, we have 4 millimeter wall thickness, and they are very massive in relation to the compact size of the entire crosshead. This is immediately noticeable in the load-bearing capacity and consistency. The symmetric course of the diagonal bracing is perfect for slinging the truss, as the nodes are now present on both sides of the main support cords in the mirror image. The structural arrangement of the position of the pins in the case of a truss lying on the floor enables very easy assembly and disassembly of the truss. The upper pins are inserted from above, and the lower pins are inserted horizontally from the side. Especially when mounted on a tour, or when being mounting on tour, I found it important to be able to visually check the correct assembly without having to check every connection with a tool. That would be the theme with the bolted system, for example. So that was the reason why I've chosen that system. So Norbert, yeah, what does the structural engineer say about that truss or the truss selection?
Yeah, please show again the screen. You've been a little too fast. From a structural point of view, this is the perfect indoor rigging truss from my point of view for several reasons. The first is, of course, when talking about an indoor show, we mostly do not have to consider any horizontal loads. I just say mostly because in some cases you have to consider as well some, let's call it an indoor wind, like a which might occur due to air conditioning systems in case of the event of fire, for example, or even when you have an installation in a, for example, in Germany, in a fair hall, which is ground supported, you have to consider as well a fraction of the wind that has to be considered outdoors as an indoor wind as well, in order to be able to calculate a proper stability against overturning. So, but this is now a ceiling suspended and hanging system. So in this case, I would not consider any horizontal loads on that. But in case you would have horizontal loads, it would be better to have a truss which has some bracings in the horizontal bottom and top plane as well. But no need for this in this case. Furthermore, with a rectangular shape, it is higher than wide. We need basically the height in order to be as stiff as possible against deflection. So the width is not necessary. From this point of view, looking on truck space, it is yeah, it's a good point to use a rectangular truss. Finally, what I like on this truss as well is basically that, Chris, can you go with your mouse, please, on the bottom node point of the diagonals with a horizontal ladder on the bottom chord and the 3D point? Yes, exactly here. When you sling a truss through the V shape of the vertical diagonals, exactly in the node where you insert the force with a round sling, for example, there's as well a horizontal brace which interconnects the adjacent main chords. That means any tension that you have within your round sling creates a horizontal pressure of the main chords together, and this is bridged, or this is stabilized by an interconnection between the main chords by the ladder tube. So from a structural point of view, it allows an easy rigging. It has proper shape for tracking. The orientation of the pins allows an easy installation. And finally, it has a quite thick main chord with 4 millimeter thickness. That means it has a high bending stiffness and results in low deflections of the truss. So from my point of view, good choice.
Yeah, yes. So let's have a look at the the other system components. Due to the length of the support truss, I've chosen a total of 6 hoists, all combined with the load monitoring system. Thus, the operator of the control has at any time the visual control of each hoist on each motor at any time, because the motor controller is positioned. It's directly beside the wall. That means you can drive, or you can do your drive operations. They can be carried out anytime in the visual mode. That means no radio is used for hoist one up or up a bump or whatever. So you have directly contact between the guys which are working on the wall and the person who's running the motor controller unit. But Norbert, another question for you now.
Yeah.
How can we calculate the point loads now? Because now it's a special system what we have created.
Yeah, it is a kind of special system, yes. And let me share my screen where I have prepared a calculation, or where I want to show from a mathematical point of view how to calculate, or what are the differences in calculating this supporting truss, or what differences occur between how you consider the weight and what kind of static system you choose. So the first question is, what I want to show is, does the load need to be considered as multiple point loads, or is it enough to consider it as a uniformly distributed load? And yeah, basically we had the total load of 1288 kilogram, and we engineers are lazy, and we simplify the gravity, which is in fact 9.81 meters per second in square. We simplified to the factor 10, so we can count as well. Roughly 1288 kilos is roughly 12.88 kilonewton. When I divide the 12.88 kilonewton on 15 meters of the screen size, it equals 0.86 kilonewton per meters. And this is now the visualization of the system. So one support on the left end, another on the right end. Here it is. The definition means it can horizontally slide, which is given by a vertically suspended, or due to the fact that it's hanging on a on chain hoists. This is the correct static definition of the system. I consider as a 16-meter long span, a 16-meter long truss with a 15-meter load applied. So there's half a meter on the beginning here open and half a meter on the end open as well. So when I count this, yeah, this is the visual view again. When I count it, I result in a bending of the design value of bending of 43.57 kilonewton meters. This, of course, would be the first step to give an indication, okay, how strong shall my truss be? Then, of course, I can calculate it as well as multiple point loads. In this case, we had the bumpers or the headers in every vertical column, one bumper and one connection to the supporting truss. That means every meter, 1 point. So it results as well in 0.86 kilonewton per point. So the difference between the calculation as a uniformly distributed load or in 15 individual point loads, there's no huge difference. It was in the previous calculation for a uniformly distributed load 43.57 kilonewton meters. Now it is 43.93. So it's basically the same. But what about if we would have different kind of bumpers or headers? If we would have a bumper for each for 5 columns in a row, that means we would have 3 point loads of 4.29 kilonewton each. This would end up in a bending of 47.69 kilonewton meters. And this is definitely not the same like 43.57. It is nearly a difference of 10%. So it makes a difference whether you or how you apply the load to the truss. It makes a difference for the resulting bending within the truss. This just should be considered. But of course, a 16-meter span for a 15-meter wide LED screen would result in way too high deflections. So let's have a look on the deflections, which are now in this example calculated for the chosen ProLight SR63R type of truss. So if we would have a 16-meter long span, it would end up in a deflection of 213 millimeters, which is definitely too much, because then you would never be able to hang the screen properly with a horizontal bottom edge, especially when you assemble line by line. You lift it again, then you assemble the next line, you lift again, assemble the next line. The deflection increases and increases, and you would have to adjust the length between the header and the truss with every assembled line. This is impossible. So let's have a look what changes when we go for a third hanging point in the center. The deflection immediately reduces from 213 to only 5.6 millimeters. So it's only 2.6% of the initial deflection. But even 5 millimeters can cause some problems when assembling the walls, especially the deflection creates a shearing between the panels in a vertical direction, and the connection from panel to panel, which is usually clamped or bolted or pinned or whatever, it is not designed for this shearing load. So therefore, I would go at least for another fourth hanging point. Then we would have a resulting deflection of 1.4 millimeters. This 1.4 millimeter, I guess this is something manageable. But I see, Chris, you would like to hook in.
No, because the single point load is too heavy. Just if you just use 4, but
exactly, that is the next question, because now we first had a look for the strength of the truss. That means the resulting bending and the resulting shearing must be checked, of course. The next is a question of the deflection, but finally we have to have a look as well on the hanging point loads, which must be handled by the chain hoist and as well by the venue. So let's have a look on the hanging point loads. When I count for 4 hanging point loads in the location like I chose in the calculation so far, with a distance of 5.33 meters between each other, then we have 538, that means roughly for 538 kilogram, and 1.56, roughly 156 kilograms. They are distributed unevenly, which can cause as well again a problem while lifting the system, because when they are loaded not equally, they will lift with a different speed. So it is advised to generate, if anyhow possible, a situation where you equalize the hanging point loads. This you can achieve when you slide the hanging point closer together and create a cantilever on the sides. There we have 3.52 versus 3.42. This is nearly equal. And now you have equally loaded chain hoists. So when we have a look now on a load of 342 kilogram per point maximum, no, 352. It's a mistake here. It should be 352. It looks like to choose a 500 kilogram chain hoist would be good advice. But how about the safe weight of the chain hoist? When you choose a 500 kilogram chain hoist, including the chain of 24 meters, you have a weight of, in this example, when you choose for an Exerise 500 kilogram D8 plus chain hoist, it is approximately 43 kilos. So if we add this again, we already have 395 kilogram per point. So when we've considered the self weight, what about a dynamic factor when you start and stop your chain hoist? A simplified rule, which is described as well in the German accident prevention regulation DGUV V17, or which has been called in the previously BGV C1, it is described as a simplified approach of 1.2. It's difficult to find exact numbers from the chain hoist manufacturers, but this is a simplified approach. So if you add this factor of plus 20%, you already have 473 kilogram per point. So it's getting more and more. Finally, whatever assembly you have, we can consider as well that the lifting of the system, you never have exactly the same lifting speed, I guess. Or this is what I strongly believe. So what happens if one of the chain hoists runs a little slower, and if it lands in the lifting height 5 millimeters lower than the others? Just remember, we had 473 kilograms so far when it's exactly leveled on the same height on the last millimeter. If you just have a difference in 5 millimeters of the second chain hoist, it shifts the loadings to 588 on the first one and 729 on the third one. So this you should always consider and take in mind when choosing when selecting the strength or the load capacity of the chain hoist. It's not bad just to choose it a number higher than you would usually do. Yeah, that's it from my point of view, from the calculation point of view. And when talking about these differences in the hanging point loads, we end up again with the advice of Chris, which we had before, using a load monitoring system, where you would like to explain something more about, Chris.
Yeah. So yeah, when I've supervised and planned a production with the use of a video wall, the use of a load monitoring is an absolutely must for me. The small distance between the hoists and as well as the fact that the drives are not synchronized can very quickly create load shifts in the entire system. And I'm not able to calculate that on site. And either then you, Norbert, can do the calculation in that way that you can think about what can happen if. So that therefore we need we have to use something which is consistently demand and implement load monitoring in terms of the budget. That means for me, it's an absolutely no-go to go out without a load monitoring.
One point from me, which I would like to add, whatever I, as a structural engineer or any other structural engineer is doing, it is theory.
Yeah,
and it never matches exactly the reality.
Yeah.
Especially when, for example, this truss, what we are talking about now, is hung on a ceiling of a venue. The ceiling of the venue reacts on the applied loads by a deflection itself. So you never, or even whatever I would calculate theoretically, I cannot take into consideration the deflection or the elastic behavior of the venue ceiling. So from that point of view, that's another good argument as well to consider a load monitoring system to get a higher level of safety.
Let's give you maybe some arguments. If you need a chain of arguments for a customer to get the budget for the load monitoring. I mean, what we are talking about? We are talking about prevention of the overload of supporting structure. We are talking about preventing the overload of electrical chain hoists, the overloading of lifting accessoires or lifting goods or things like lifting attachments. We prevent unintended stress in the video wall, what Norbert remains before, the stress or Norbert, sorry.
Sorry, I just didn't follow you because I read some questions in between.
No problem. Stress and strain, something in some countries is stress and strain more American or more English, doesn't matter. So you know what I mean with stress in the whole system.
Yeah.
And also, if we have some kind of load monitoring, we have the feature of the group deactivation by connecting the motor control hoist system directly with the load monitoring system. And also, when used in a group, each channel of the load monitoring can be set individually as an upper and lower load limit. So you see the 6 digits here from the 6 hoists. So you see the maximum amount as the maximum weight was 8.27 kilonewton. We have to add the self weight of the hoist plus on top because this load cell is sitting between the hoist and the truss.
Just one point in between. There's one question from a participant who is asking, do I really have to calculate the self weight of the hoist into the maximum WLL? Yes, of course. If in case you have at least the load capacity of the chain hoist, when it's called 500 kilogram, then it describes the ability of the machine inside to lift a certain weight. And the clutch and the brake as well is designed for this kind of weight. When you assemble the chain hoist upside down, that means that you have the body hook on the truss and the chain hoist needs to be lifted, including the truss, then of course the machine must be able to lift its self-weight as well. So yes, you need to consider the self-weight of the hoist into the load capacity of the hoist. And one other question was concerning my calculation, my previous calculation. If I consider the self-weight of the truss, to be honest, I'm not really sure if I considered it in my simplified calculation, but of course you need to do that.
Yeah. The next thing is let's speak about the different systems, Norbert. The difference between statically determined and indetermined.
Yes, that's another interesting point.
Stefan is also there.
I would like to add my 2 cents as well to the load monitoring system. And
yes,
I don't know how many people we actually have in the audience right now that are responsible for planning budgets and things like that. The one thing that I would like to point out is that there is a unbalance in terms of information. Meaning, what I mean by that is, for instance, in the audio department, we know exactly when the guy is turning the knob on his console a little bit. We can measure easily and we know exactly how loud that audio is. In the lighting department, we take a meter, we can measure exactly how bright that lighting is, and we know exactly we can raise that a % up or down. In the video department, we know everything to the pixel precise. We're processing everything. The timing is done to the frame, which is a 60th of a second. And we have all that information. The only department where we start guessing is the department that can possibly kill or hurt somebody. And there is simply in our industry an imbalance of information. We need to be able to give those riggers the ability to get a real-time reading what's going on in my system, just like an audio guy, just like a video guy, or just like a lighting guy. How many %, what's going on, what can I do with my system? And that only a load monitor system gives us exactly that.
Just one point in between. I've just created Fastly a poll just with a question: if you use so far a load monitoring system to control the loads per hanging point, just be truthful, give me the favor, just say yes or no. It would, oh, sorry. I just wrote, I see I made a mistake before I launched, before I launch it. I just typed yes and 9. 9, of course, means no, sorry. But it's just launched. Just, yeah, give us a hint where we are in the reality. I will give you an answer later, Chris and Stefan, but I'm looking forward for the result. Okay. Chris, you're muted again.
Yes, I can't choose. Sorry, I can't use the poll. Okay.
You not, but I see already that the answers are coming in.
Yeah.
Our opinion doesn't matter. We're excluded from that.
Better it is. So Norbert, I stopped my presentation that you can explain the system, yeah?
Yes, okay.
Yeah.
Let me have a look. Where am I with my presentation?
Yeah.
Yeah, not well prepared again. We've discussed it already up front. So here we are. So this on the left here is a screenshot from the German code of practice SQP2, which is about electric chain hoists. And there's one chapter, 4.2.4, which is protection against overload. And here is written, in this chapter is basically written in English, the load measurement is always required if there is a risk of overloading individual elements in the distribution of forces. The danger of overloading individual elements in the distribution of forces often exists with statically indeterminate load systems. So the question is, what the hell is an indeterminate system? This to explain, I've prepared a few examples. Let's consider a single span beam with a length of 6 meters with one center point load of 100 kilogram. When I do not consider the self-weight of the truss and do not consider the self-weight of the chain hoist, the reaction on the hanging point will be 50 kilogram and 50 kilogram. So just mentioned in the beginning, it is a very simplified explanation of what a statically determinate or indeterminate system is. And it is, all the explanation refers only on a hanging structure. Please, this you must consider. So 100 kilogram point load in the center, 50-50 on both sides. So when a slight change of the lifting height of one of the chain hoists, either the right one or the left one, does not affect the supporting reaction, then it is a statically determinate system. In case I add a third hanging point, the reactions are 33, 134, and 33 kilogram. So it's not 1/3 on the left, 1/3 in the middle, 1/3 on the right chain hoist. So what happens when the middle chain hoist runs 8 millimeters lower due to the fact that it's loaded higher than the others? The result is that the middle chain hoist does not see any load anymore, only because of deflection of 8 millimeters in the center. So a slight change on the lifting height of one of these three chain hoists, especially in this case, the middle one, does affect the resulting hanging point load. Then this is an indication for a statically indeterminate system. Another example is when you have a hanging triangle with 3 center point loads of 100 kilogram each. The resulting hanging point load would be 100 kilogram in the corners. Here again, what happens if one of the chain hoists lifts a little higher or lower than the others? Does it affect the resulting hanging point load? No, it does not. So that means this is a statically determined system. But what about having a square hanging in the 4 corners with 4 center point loads? When all chain hoists are in exactly the same height, and when I talk exactly, I mean exactly, that means exactly on the last millimeter, the resulting load is 100 kilogram in the corners again. Once again, the self-weight of the truss and of the chain hoist is not considered. If one of the chain hoists is running 8 millimeters lower than the others, for whatever reason, there will be a shifting of the load from 100 to 96 and 104. So in this case, it is not that significant as in the continuous beam. But here we have the effect that a slight change of the lifting height does change the support reactions. That means it is a statically indeterminate system. So now we are focused on the hanging point reactions. So this is one way to imagine if it is a statically determinate or indeterminate system. Another way is as well that we can imagine, let's start again at the beginning, a single span beam, 6 meter span. What happens if one of the chain hoist fails? When it fails, it will swing down. Simple as that. This imagination means it has been, when it was hanging on 2 points, it was a statically determinate system. What happens if we have the same thing where it's a continuous beam, 2 times 3 meter span? If the very right chain hoist will fail, what happens? It basically will still hang. It will not come down in case the truss is capable to hold the load, and in case the chain hoist is capable to hold the load. And in case it is loaded and balanced, it will still hang, and nothing will happen. So this is another indication of a statically indeterminate system. So the same idea we can approach on the triangle. And if this fails, if this chain hoist or hanging point fails, it will swing down, it will fall down. That means it has been a statically determinate system. And for a square, in case one of the support fails, and in case it is loaded and balanced, it will still hang, it will not move. That means it was a statically indeterminate system. Here again, whatever an engineer calculates, it's only theory. That's it from my side when talking about statically determinate and indeterminate systems. So Chris, what about you again? We've done now so far the selection of the system. We've been talking about the load monitoring. How do you continue?
Okay, so now we want to continue to create the original plot, which is going out to the local promoter and to the venues. That means I started with a preliminary plot and I started to collect informations. So the next step will be I have to bring everything together. That means I need to have the information about the stage size, including the side wings. I need to have the relevant contact person due to the lighting questions and sound questions and video questions. Then I have to think about, for example, if I have to expect dynamic forces due to automation, for example. But in this case, we are not trying to move the wall during the show up and down. So, but it's a step. I have to think about that to that time before I send out the plot. And also the last question is for me really important. Do we have technicians working at height? For example, spot operators, focus technicians, any kind of troubleshooting persons for video vaults. I don't know, maybe Stefan can tell us a bit more about that then later. But this is really important because what I want to do is I want to avoid working at height. That sounds a bit strange for you if that comes out of the mouth of a rigger, but yeah, to bring in other things, or I mean, avoiding working at height means that I don't want to have anybody working on the truss, for example, to go up with a ladder and moving horizontally and yeah, things like that. So, but Stefan, are you still there? Yeah, you're still
yeah,
awake. Okay,
still awake.
So
yeah.
Maybe you can jump in now and give us yeah, how does it look with you at this point?
All right, so so we talked about all the, you see my screen, right? Yeah. All right. So we talked about obviously all the system selection, etc. And now that it goes into the phase of nailing down the design. On my end, what I usually do is I simply start compiling all the documentation necessary. I talked about it, that I make my drawing, I make my gear list, and obviously everything that was just discussed between Chris and Norbert, that is obviously in the real world, there can be some changes in minor details, etc. So, and that basically then trickle back to me, that causes me to make adjustments or anything, whether it's adding hanging points or reducing hanging points based on what the truss selection and the gear selection was, and all stuff like that. So to make that data package together, I obviously take the LED data sheets. I'm taking information from any rigging hardware, turnbuckles, for instance. I can't expect, there is no standardized system across those hardware. So I need to share that, what I'm providing, etc. If there's any custom hardware that is proprietary to either to the LED product or that was afterwards custom designed for that particular show, there needs to be obviously some sort of documentation there, detailed drawing for that part or whatever it might be. Then any sort of test reports from the manufacturers. And of course, we're talking here on our example on a tour. If we have somewhere a little 3x4 panel display somewhere on a convention, I don't think it's super necessary if it's ground supported that there is a manufacturing test report being shared. However, I like all my people involved to know, hey, it's available if the information is needed. I have it on my computer. I can share it at any given time. And the same with any sorts of engineering reports from the manufacturer that specifies maximum hanging, how many panels can I hang in a row or in a column, and all those things. What's a maximum, and what does a manufacturer basically dictates what I can and cannot do. Like I said, if necessary, I'm updating my LED drawing, that once a package is passed on to the rigger, that they have an updated data that they can travel with, and it's basically the whole package. And all that data, again, it depends if a structural engineer is necessary for that particular show, especially when it's a custom LED solution. Then I actually go by default to a structural engineer as well as outdoor. There's no better insurance for me as a video supplier than having the sign off from a structural engineer that at least the part that I contributed is properly done. And that's basically what's happening on my end. Once all that stuff is done, that package gets all bundled up, gets sent over to the rigger, and there you go. Here is your LED related structural information, everything you need to know. And that's basically what I got. And that goes straight back to the rigger.
Okay, so.
Yeah, not straight back to you.
No?
Just, no. I just wanted, yeah, I just wanted to raise my voice. I had a look on the poll about about whether our participants of this webinar use already a load monitoring system or not. So far, only 80% of the participants participated as well in the poll. So there are still theoretically some answers open. But so far, 40% use already a load monitoring system and 60% not. So there are still some answers open. Let me be evil and say, okay, they do not answer because they do not want to show up. Yes, I don't use it yet. So yeah, I see basically there's still definitely the necessity to vote or to shout out loud and to point out again and again that it's necessary to use a load monitoring system to rig safe. Chris, back to you.
Absolutely. Okay, so let's continue. But we've the next part is I call it execution planning. That means for me, it's about the coordinating of handover points between lighting, sound, video, rigging, and also the timing in the daily schedule between rigging and video, for example, for our specific example. What we have to do is, where is the rigging team passing things over to the video crew? Who is doing, who's running the hoist control, for example? Who is building the truss? Who's getting in charge with the load monitoring system, for example? But the main question for me is always the service concept. I have to play the ball now again back to Stefan, because I'm not in charge with the video system. I'm just a rigger. But if a video system is not running, I'm sure that there will be also troubleshooting anyway, anyhow. So Stefan, what is your idea about that, the service concept?
All right. So obviously, once we hang that LED wall, everybody that ever used an LED panel knows there's obviously some sort of problem, whether it's a loose cable, a loose data, loose power, loose pixel module, you name it, there's always something necessary to deal with. So basically, the big question in the room is, how do we do the service? The first question that we need to address, what does it take to do any service on that? For instance, the example of the Vanish that we used, that is front serviceable. Some other products have rear service where there are some sort of screws that need to be undone in order to change modules out. Obviously, you need rear service to get to the cables, etc., and so on. So, and in some cases, like in our particular example, where the modules being changed in the front, but the cables are in the back, we basically need access on both sides of the screen. So the question is then, how do we get there? Do we have somebody climbing there? Do we have a work platform, a scissor lift, a cherry picker? What do we have? What capabilities do we have locally here in the United States? We have venues that are somewhere 90 meters tall. I'm pretty sure there's very small selection of work platforms that can get there. So, and that simply needs to be looked at. Obviously, if there is, what kind of obstacles are we dealing with? If we're having work platforms or scissor lifts or any of that stuff, what are the limitations? Can we get to the entire screen? If there's a stage, then we can't obviously drive on that thing. So things like that need to be discussed. The next step would be, what safety measures do we need? Obviously, there's typical things like we fix it on a timely fashion if nobody is in the room. If we have to work at height, we can deal with it that way. We need to have proper safety equipment there. If somebody has to climb there, we need to have horizontal and vertical lifelines, and all kind of just go through the whole repertoire of safety equipment and what's necessary to keep everybody safe there. The other question is, what kind of time window do we have to do any kind of service? We have a support band, we have a main act, there is a 15-minute changeover. Is that 15 minutes enough, or do we or do we need any longer? What's the size of our problem? What do we actually need to service there, you know? And then the last question is basically, who's doing the service? There is, especially here in the United States, there is so many different politics about who's climbing where, when, who is allowed to drive any heavy equipment, scissor lifts, etc. And that basically needs to be considered and spoken about. If, for instance, a rigger is the only person that's allowed to climb in that building and has to do that, obviously on our video side, we need to make sure that that rigger knows exactly what I need him to do. Pull the cable out, plug it back in, do a power cycle or whatever it is. And we need to make sure that they know exactly where the service and how the service has to take place. And that's basically the major points of it all.
Okay. Yeah, you see, there's a big difference between what is your concept, what is my concept, because if you're checking the point loads, for example, then you say, okay, maybe we need horizontal lifelines, blah, blah, blah. And I say, okay, in case that I don't know that that will be your system and your design troubleshooting idea or whatever, then I'm not able to calculate that into the point loads. That means I have not included any person who climbs the truss and in the worst case creates a high impact force. I don't do that because that in my first step is the question why I try to avoid working at height. That means I don't have to deal with impact forces, which I can't touch them. Yeah. Okay, but yeah, to go on the next step, staff planning, and for installation and dismantling. Staff planning means how many tool riggers do I have to use? Do I have to plan? Do I have to calculate? So I have some parameters which are important for me. The number of the hoists is the first parameter, yeah. The transfer points, who is operating the hoist control system during load out, load in, load out. And I've talked about that before. In case of a support truss between the video wall and the hoist, who is responsible for assembly and disassembly of the truss? Is it part of the rigging team? Is it part of the video team? Is it part of somewhere else or somebody else? I don't know. In case of the load monitoring system, who's responsible for assembly and disassembly the load monitoring system? These are the questions and these are the parameters, and you have to speak with the other departments to clarify that before the tour starts. I mean, in our case, the rigging team did the assembly of the support truss and also the load in of the load monitoring system. That means we built it, we prepared it for the video technicians, and we passed it to them. Definitely, it was the whole system was done pretty well. The load monitoring system has been checked. So to that time, where the video crew jumped over and took the truss and the hoist control system, then everything was well transferred in my world. Okay, so yeah. I think it's now your part again, Steph, isn't it?
Is it? No?
Yes.
Is it already? All right, cool. Well, daily responsibilities, right? All righty. Sharing. Where we're at here. Share, and there we go. So, daily responsibilities, and that is fairly similar, obviously, in most of the departments, because safety is safety. So we all want to go home to our families, and so that's basically the important thing. The one thing is, safety aspects are subject to review and modification on each new location. No venue is, no two venues are the same. So obviously there's different hazards in different venues, different buildings, indoor, outdoor, you name it. And obviously things like that need to be considered. That means there's usually a safety meeting in the morning, and we basically strive for that there's an active participation. Just holding your coffee and sitting there is just simply not good enough. Be active part of the whole thing. If you know anything, the same old, if you see something, say something, same thing. If you have anything relevant, safety relevant aspects to share it during the meeting, that everybody gets that information there. If you have any risks that are in height, obviously you need to inform your head rigger about that. You need to have a talk and basically make the guy that is in charge of everything that's happening overhead, you need to make him aware of it and find a solution for any of that stuff. If you have people working in height, obviously you need to develop with your riggers together a rescue plan, because what happens if there's an accident and now the guy can't help himself anymore? We better have a plan. And here in the US, there is this saying going around, 911 is not a rescue plan. So that's basically it. You cannot rely on the fire department to get there in time and catch me when I can. So that's just, it just doesn't work like that. We need to help ourselves, because by the time the fire department shows up, it could be already too late. Work out an operations management plan. That's actually something in the United States that is required. It's not even a question. You need to have a plan. This is mostly used outdoors. There is just a handful of points that I can think of that would require indoors an operation manual management plan. An operations management plan addresses, for instance, if there's an outdoor screen, at which wind speed are we lowering the screens? What are we doing? Are we just lowering it to the ground? Are we strapping it additionally? Who is lowering it? Who is saying, has a final say, and hey, we need to start acting, and things like that. Those are all written down and spoken about in the operations management plan, because if you start having a discussion, should we or should we not lower a screen or address some sort of safety concern, it's already too late by the time that issue arises when you just have the conversation about it. This should be addressed prior to that. Similar goes into effect. We need to make service, so that needs to be addressed beforehand. And then the biggest, or one of the biggest points for me is basically select qualified crew. If you know you're going on a tour, you need to have an LED technician that is comfortable wearing a harness, that knows his way around on lifelines, etc. And basically that part is all part of the qualification. And having a technician that is not comfortable in height in those kind of setups is just not efficient, doesn't help anybody, doesn't help the person, doesn't help the production, and therefore it needs to be properly addressed, and proper qualification is important in any aspect. And last but not least, obviously, perform a visual inspection of your equipment that's being used. Give it a look over on a day-to-day basis. Make sure that all your rigging equipment, your headers, your latches, your locks, your shackles, you name it, that they're rust-free, that they're properly in proper conditions, and that they can be used and taken care of. If something dropped the night on the loadout before, take it out of service, give it a look over, and make sure that your that your equipment is in proper working conditions. And that's pretty much close to that.
Yeah, I think I was a bit quick to pass you the word. I don't want to disturb you, but okay.
But it's now already getting back to you, Chris. And when I have a look on our schedule, we're coming close to the end already, right?
Yeah. No problem.
Perfect in time. I'm surprised.
Yeah. So I mean, to just wrap up the point, the daily responsibilities and the theory of the risk assessment. Of course, we are all interested in ensuring that no accidents occur, in our day-to-day business. Therefore, it's important to coordinate all the individual work steps on a workday while implementing the existing risk assessment. But I have some measures which can be implemented every day. For example, safety meeting, work instruction before starting the work. That means it's a part of the department supervisor or the crew chief. The visual inspection of all work equipment before each use, the most important point in our day-to-day touring business. The clear separation of tasks between the departments, who takes over which activity, and the coordination of the construction times of the individual departments in order to avoid, for example, overhead work. Follow the risk assessment plan controlled by the department supervisor or crew chief. I mean, risk assessment is really important. And what do we have there? I mean, the thing with risk assessment is real. It's clearly, we have the individual risk assessment that ensures that all those who are involved know and can implement the measures to be complied with. But for this purpose, these assessments must also be made available to the persons concerned. In our case, it means all persons involved in the construction and the use of the wall. I mean, it is not of use if it rots on the desk of someone responsible in some office. You need to have it on site. You have to pass the information to everybody who's in charge, involved in that piece.
Chris, here one question. Please go one slide back, please. No, not forward. Backwards, please.
Yeah. It's running.
It's running. Okay.
Yes.
Runaway slide.
The slide that you've shown before was basically your kind of risk assessment that you've performed before the tour. And do you have any source, or where do you from where did you take this kind of overview?
Many informations are from the, we call it Germany, yeah, Berufsgenossenschaft, you know, the health and safety organization. And
so it's basically, I just would like to point out a little more, because everything is written in German, not everybody might understand, but here are described different type of hazards, mechanical hazards, electric hazards. Stefan, help me, what is Gefahrstoffe in English?
Hazardous materials.
Yes. Yeah. Fire and explosion hazards, thermic hazards, and so on. And
we need to have 2 more sessions to explain the risk assessment and to get it started.
Yes, of course, but it's just a very rough, very short look in it. So the risk is indicated with low, medium, or high, and then describe the measures that needs to be taken to care about these hazards and who is responsible for that. So this must be made every installation again, and this is just what I wanted to point out and explain again what this kind of slide was about. Now I break it.
Yeah, no problem. Yeah. I'm sure that every participation who's running, who's sitting on the other side of the wire here, I think the theme risk assessment is yeah, it's nothing new, but sorry about interrupting you for that. But I don't want to start here, because if I have to start there, then I need a lot of more hours to explain things. Yeah. Okay. So yeah, my last page is, or my last thing is, what do we want to do now? We have to do maybe think about troubleshootings or concepts for the day-to-day business if something is not running in that way as it has to be. So I start in the warehouse. I start in the warehouse because I want to, when we assemble the material, that means when we are checking the rigging stuff, the hoists and the lifting accessoires, for example, we have the time, the possibility to check every component. With the hoist, we make sure that the regular inspection, the expert inspection, has been carried out on time. Hoists have to be inspected once a year by an expert, we say in Germany. I don't know how you say it in America, Stefan. We say expert means it's a person who carried out the inspection and who's recording it. Yeah.
In the United States, it's there's a differentiation. It's a qualified person and a competent person. So the expert would be the qualified person.
Yeah. Okay. Yeah, this here is sum of all points what we've talked about before. So we have the visual inspection prior to the use. We have the service procedure for the wall. We have to use the service plan. Does the service plan require additional equipment, for example, scissor lifts, to maintain the video wall? And not only equipment, also space, for example. It's a question of the design area. Where is the video wall located? Can we reach the video wall, or can we reach the single modules via a scissor lift or other things? And also the client structure must be dimensioned in such a way that in the event of the fall, the resulting shock load can be absorbed by the lifeline system. So that means shock load depends on the used system. Yeah, it can be from to. It's no fixed amount what we can calculate. If a technician, a rigger, or anybody else is working at height, the rescue plan must be prepared. Shall be, must be, shall be. We've talked about shall and must, yeah? So shall be prepared. The rescue plan shall also specifically assign the rescuer. In Germany, we are required to execute the rescue procedure from within the rigging crew. That means we don't go on the phone and ask somebody who can help us. We must be prepared in that way that we can organize it from our own crew. Yeah, I think that's the best way to, the best way is to prevent working at height. Okay, but if we have to do so, then the rescue plan is basic. Yeah, that's it from my side.
I guess we have forgot one slide of Steph, correct?
Yeah, I got one add-on, but it fits basically in because it's safety related. So it's not the end of the world here. Let's just go through it really quick. Here we go. All righty. So when we talk about safety, obviously, the one thing that I cannot stress enough, if I can find my mouse. Hello, where are you? Where is it? Oh, there on the screen. There you go. Sorry. It's late. Even the mice are tired here. All righty. So LED components are not anchor points to be used with your personal safety equipment. So all those frames that you're climbing on, all those bits and pieces from an LED wall is not an anchor point to clip your safety point in, unless, here's a big unless it's designed to do so. An anchor point based on OSHA requirement here in the United States, OSHA is the Occupational Safety and Health, what are they called? I wrote it down. Administration. It's a governmental thing, so it's an administration. It requires that an anchor point has a capability of holding 5,000 pounds or 22 kilonewtons. If an LED wall would be capable of holding 5,000 pounds, we wouldn't have that seminar right now. So that's just an LED component is not an anchor point.
Yeah, wait a second, please. It's not only about the LED panel, it is mostly
everything in the system.
Yeah, mostly not as well the supporting truss.
Yeah. That's what that second point is here addressing. Yeah. A climbed structure must be obviously dimensioned in such a way that in the case of a fall, that it can withstand those loads and that all the anchor points and lifelines are properly dimensioned, obviously. As a good resource, how a structure for LED screens or temporary video displays here in the US has to be handled and worked with is the ANSI standard E1.50. The ESTA, which is the institution here in the United States that deals with all kind of entertainment related things, they have a technical standards program, and that technical standard program is basically designing and making those ANSI standards. And the beautiful thing about the entertainment side of those ANSI standards is that the ESTA found a sponsor that makes those ANSI standards for free and available to everybody. So they can be downloaded and looked at. They're usually 7-8 pages long, so it's not you don't have to have a law degree to understand all those things, and they are really helpful. They make a lot of references to other documents that are necessary and important, and I only can urge everybody to look into those things. So yeah, and I think now we're really close to the end. I think there's Q&As, correct?
Yeah, basically that's it from our side. I can.
Do you have a closing slide or something?
Yes, I do. I do. Wait
okay,
a second.
well, then it's all you.
I do have. Ta-da!
I'm past my bedtime. Let's go.
Yeah. No hurry. So, yeah, from our side, that's it. We thank a lot for your attendance, for your time to listen to us talking about safety and rigging an LED screen and how to plan it properly before the tour, before the show. You see here our email addresses. So in case you have any more questions, just get out, reach out to us. No problem. More than welcome. Just one final comment again on the poll. Now, 92%, 94% have participated, and the answer is basically 44% of you do not use a load monitoring system yet. 56% say no, sorry. 44% do use or already uses a more load monitoring system. 56% do not use it yet. So hopefully this webinar change your mind a little to look for it in future. I see there's one more question. There was already one question that someone was asking about the preciseness of load monitoring systems, and he has been told in the past that load monitoring systems inside the body of a chain hoist are usually more precise than an external load monitoring system. This I would not sign to 100%. It depends on how the system works. Basically a load monitoring system works on measuring elastic deformations within the device. And this elastic deformation we are talking about micromillimeters. And the preciseness of the load monitoring system depends on how the load is applied. So there are different systems available, and some systems have benefits, some are better, some are worse, but it depends on, it has nothing to do with internal or external, it has something to do with how the system works. So some systems have according to my knowledge, a preciseness of plus minus 1 or 2 kilogram. Some have a preciseness of only of plus minus 30 kilogram. It depends on the system, but it has nothing to do with internally or externally of the body. Chris, do you agree?
Yes, absolutely.
Yeah, okay.
Good.
Then I'm lucky. Okay.
Me too.
One more question. Oh no, this was answered. Yeah, okay. So there's no more open questions as far as I can see.
Good.
So do you want to add something, Steph and Chris?
Good night.
Fine. Thank you. Thanks for this first run through, and yeah.
Yes.
Okay,
Thanks everybody for participating, for coming, showing up, and taking the time to talk about that.
Yeah.
Okay. So
Yes.
it's up to me just to wish you a nice day, Chris. You have a nice sleep, Steph. And
Thank you.
see you soon.
Yeah.
Bye-bye.
Definitely.
Bye-bye. So, bye
See
for
you
the
guys.
rest.
All right.